So if you think you need more help with page 8, which is what this one is, go ahead and it says explain how the criteria for triangle congruency, so ASA, SAS, SSS, and HL. I made Khan Academy videos, or I linked them and made assignments. There's a lot of stuff for this. Feel free to use YouTube and things like that. There's a lot of stuff for triangle congruency. That's what you'd want to look up. So it wants us to solve for x. Well, look at how these two triangles, right? We got side, angle, side. Side, angle, side. What that means is that the triangles are congruent. SAS proves that these triangles are exactly the same. So from this angle, across from it is a 19. This is the same angle across from it is x minus 4. If SAS proves that the triangles are perfectly the same, that means the side that is x minus 4 has to be the same as 23. Or excuse me, 19. So I got to add 4, and that gives us x is 23. What additional information is needed to show that ABC is congruent by SSS, which means all three sides are exactly the same? So right now we got one set of sides. We got two sets of sides. That means that we need to know that this side is the same as this side. So CA is congruent to FD. That's what we need to know. How do I know that it's in that order, like CA and not maybe like AC and F? I just picked C to A, and A is the one with the angle. That means I need to pick F to go to the one which is the one with the angle D. Okay, so for two triangles with identical orientation, what this means is that they are upright in the same way. So what, like if I have a person here and I draw them right here, they have the same orientation. They're both upright. But then if I draw the person like this is the same person, but the orientation is not the same. Like they're laying down. They're not pointed up the same way. So these triangles are perfectly the way that they are. So what rigid motion is necessary for SAS to prove side, angle, side? I think they're just trying to confuse you a little bit. If you know that these are congruent images and they're already facing the same way, you know, think about which one doesn't change the way that they're standing up. You know, a dilation is not rigid. You're going to change the size of it, so that's not going to work. A reflection flips this thing. Either flips it over that line or over that line. It's not going to be exactly the same. A rotation will turn it around. So to show that they're congruent, you would just translate it. You would bring this one over and then put it on top of it. Right, and what I mean by that is, let me see if I can. Right, so this is a translation. I'm just picking it up and dropping it on top. That shows that they're congruent. Okay, so they're giving us this information, and I think immediately I'm reading part A, and it says the given information matches the SAS. So whenever you're thinking SAS, ASA, all these different things, you like to actually see the triangles. So let's draw them. We got A, B, C, and we don't know what they look like, but just draw some plain triangles. I started with A over here at the bottom left. I'm going to start D at the bottom left, E, F. And let's mark what's given. A is the same as D. B is the same as E. And it says BC is the same as EF. Given the information, which statement is true? Well, this is not SAS or ASA, right? Because this says angle, angle, side. So we're given angle, angle, side. Now stop to think, okay, does that mean they are congruent? Does AAS work? So yes, they are congruent. The given information matches SAS, no. ASA, no. Angles C and F are also congruent. This must be shown before using the ASA criterion. This is an odd question. It cannot be shown that the triangles are necessarily congruent. Well, that can't be right because we know they are. AAS, AD, angle C and F are also. Oh, I get it. Yeah, okay. The answer is C. Right now, you cannot. So it says angle C and angle F are also congruent. We know that because yes, AAS proves that they are perfectly the same, which means every single part. We know that the other two angles are the same. We know that AB is the same as DE. We know AC is the same as DF. But it's saying like right now you can't use ASA, but you can prove you know that these two angles are congruent, and you need to do that before you can actually use ASA. Because right now with just this information you can't. So let me restate that. The given information right here, you cannot use ASA. So they're saying, hey, you need to show that these two angles are congruent, and you know that because AAS works, and you need to use that before you can use ASA, because right now you don't have ASA.